So we're live. So we're going to talk about. I gave you some of these conjectures, Mister back in the corner, Greg. So I gave you some of these conjectures, and now we're going to actually prove a few of these conjectures. They're not like super hard, but conjectures are conjectures until we prove them, and then they're actually called theorems. Okay, but in this book, they call everything conjectures. But once I have proven something, I can use it to prove something else. So what I'm trying to prove here, look at the bottom, CD is a median. So that is one of our conjectures. In other words, I'm trying to prove that this piece cuts this in half, right? Or goes to the midpoint. So in order to prove that it is a median, which two pieces would I have to show are congruent?
AC and DB.
Right? I'm trying to show that these two things are congruent, correct? Hello? Okay. Well, let's look at what I'm given. I'm given that CD is an altitude. How do I know that CD is an altitude? It's given, right? Okay. Given, how do I know that ADC and BDCs are right angles? Definition of an altitude, okay? How do I know that AC is congruent to BC? Because it's given, because it's an isosceles triangle. So I would mark that up, okay? You know that those two things are congruent. You know that because ADC is and BDC are right angles, what has to be true about ADC and BDC? They're congruent because I would just put in there all right angles are congruent, okay? All right angles, you have to have a reason for everything, are congruent, okay? So I have AC is congruent to BC, and because AC is congruent to BC, I know that angle A has to be congruent to angle B, okay? So I know that angle A, I'm going to mark that, is congruent to angle B. How do I know that angle A is congruent to angle B? Yeah, we have an isosceles triangle conjecture that says if it's an isosceles triangle, the base angles are congruent. So you can say isosceles triangle conjecture, or you can say something like base angles of an isosceles isosceles triangle are congruent. That would be better than writing the isosceles triangle conjecture. So I have a side, I have an angle. What else do I need?
Another side.
I need another side. Oh, I have another angle, right? I have a side and angle, and I have an angle, right? So, wait, is that enough?
You already did that one. We need to prove that it's an altitude at the top.
I need,
Oh, it's a bisector.
Because ACD.
so I already have that. So what else? So I have enough to say these triangles are congruent. Angle, angle, and side, right? I have this side. I have that angle. I have the right angles, right? I have the right angles. I have the base angles. And I have this side. So angle, angle, side, is that a way to prove triangles are congruent? Yes, that works. But apparently, they want something else here. What goes here? What do you think?
ACD is congruent to BCD?
No, what's congruent in both triangles?
Oh.
CD is in both triangles, right? So, I mean, and really, you do not actually need to do this because we already have an angle, angle, side, right? So this is kind of overkill. But if I did use this, then I can say, watch this. Watch how high-tech I am. Watch this, okay? I'm going to put another box right here. Whoa. Okay. So now I can say that because of that stuff, triangle ACD, right? ACD is congruent to triangle BCD, okay? BCD. How do I know that?
CPCTC.
No.
Good try, Greg.
Side angle angle, or angle angle side, whatever you want to call it. We'll call it SAA. Because of that, can I get over to here? I think I can. Okay, now I'm going to do another arrow over to here. Ooh, that's not an arrow. But I'm going to put an arrow on the end. Okay, arrow over here. I'm going to make another box. Did you run out of room on your paper?
Maybe.
And that allows me to say that these two things are congruent, okay? That AD is congruent to, I'm going to call it BD. How do I know that? I heard it before. See, that's CPCTC. Because once I have proven the triangle is congruent, then you could say those parts are congruent. I'm almost at the end, okay? That's not quite what I'm trying to prove. I need to say this now. So I'm going to draw one more arrow in there. I'm going to put an arrow on the end this time, okay? And I'm going to say because of that, boom, 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 because I know that these two pieces are congruent, that must mean that CD is a median. Who can tell me what goes there? What's the reason? What's the reason?
The median connects the midpoint to the vertex.
Yeah, you could, yeah, so midpoint connects the midpoint to the vertex. You could call that the definition of a median, right? Def of a median, it goes from here to the midpoint, or to two congruent pieces. Definition of a median, okay? And so that's what that proof looks like. Did you follow that?
Yeah.
Okay, so now we're going to do one all without any boxes. So you might have to do this at some point in your geometry career. So you should learn how to do one without any boxes. Where's the one without any boxes?
Number 8.
Number 8. Number 8.
All the way.
So this is kind of a very similar one, okay? And so let's make some boxes. Let's first look at what we're trying to prove. Write a flowchart proof for this conjecture. In an isosceles triangle, the median to the base is also the angle bisector of the triangle. So before I do anything, what things can I mark up on this picture? What can I mark up? A, B, so isosceles triangle. So what does that tell me if it's an isosceles triangle? That AC is congruent to BC. It also says triangle AC and median CD. So what does it tell me if it's a median? Which two pieces does that make congruent? Right? You know that this piece has to be congruent to that piece because it's a median, right? What else do I know is congruent?
Angle A and angle B.
You could say angle A and angle B, or what else could I use to prove these triangles are congruent?
C and D are right angles.
Right? You can use this as well. No, you can use this, right? Same side. So now do I have three things to prove my triangles are congruent?
Yes.
By SSS. Now, how would I get what I'm trying to show, CD bisects ACB? Well, in order for it to bisect ABC, ACB, which two angles would need to be congruent? I'm going to cheat. Which two angles would need to be congruent?
1 and 2.
1 and 2, right? So, do you kind of understand how I planned that out before? So, if I can prove that angle 1s and 2 are congruent, I can say that CD bisects ACB, but first I have to prove the triangle is congruent. We have seen that I have enough information to show that the triangles are congruent, all right? So I'm going to make some boxes, okay? Isosceles triangle, ABC. So first I'm going to say is that, let's make some boxes. First I'm going to put in my, I'm going to put two boxes right here. One box here. I'm going to put another box here. I'm going to say in one box that isosceles triangle ABC is isosc, right? How do I know that?
Given.
It's given, okay? The other thing I'm going to say is that CD is a median, okay? Median. How do I know that?
Given.
It's given, okay? So now I'm going to take those two things, this one and this one, and that allows me to say two things, okay? it allows me to say that one side AC is congruent to side BC. How do I know AC is congruent to BC? Very good. It's an isosceles triangle. Well, let's change colors. Red is making me anxious. Okay. Def of isosceles triangle. Okay. If you put given there, that'd be okay too, because it says isosceles triangle with AC congruent to BC, right? So if you put given there, that'd be okay too. But what does this median tell you? What does this being a median tell you?
AD and DB.
That AD is congruent to DB, right? So now I can write that AD is congruent to BD, and that is definition of a median. Def of a median. So I have a side here, I have a side here. I need one more thing. What's my one more thing that I used?
CD is congruent.
This shared side, right? So now I'm going to put another box down here, and I'm going to say that CD is congruent to CD, because it is a shared side. Shared side. And I'm going to take those three things, boom, boom. I love my Mobi board. It's so cool. I can do all this cool stuff with it. Okay, it's not a Mobi board. It's a tablet. I'm going to go like this. And these three things allow me to say what? Thank you. Very good, Joey. ACD is congruent to BCD. Okay? How do I know that? What? How did I know that? SSS, right? Which then allows me to say by CPCTC that what's congruent to what? Who's got the next step?
Angle 1 is congruent.
Very nice. Angle 1, the whole reason I set up these triangles to be congruent, now I could say that angle 1 is congruent to angle 2 because of CPCTC. And finally, I can say, I'm going to go back this way because I'm running out of room. And finally, I can say that, well, that was cool, that CD bisects angle ACB. Who knows what that is? Right? Angle 1 is congruent to angle 2, therefore it is a what? Angle bisector. So what's the reason for this? Definition of an angle bisector. Okay? An angle bisector. Okay? And that's what that proof would look like. Do you think you could do one kind of like that? Maybe? No. Some of you can. You'll get some practice. All right? So your homework is just, I'm going to pause for station identification. Hello, groovy guys. How you doing? Okay.